Welcome back, everyone. We're on to 3.3, prime numbers. So quick reminder, please like and subscribe. It helps get the video out to other people who might need this course, so really appreciate that. But jumping into this, we're talking about prime numbers. So prime numbers is something you've probably come across before in math before. I know I keep referring to Beast Academy because that's what I'm familiar with. But if you did Beast Academy, then I know you've come across prime numbers before. This is a fairly simple, straightforward lesson. So some of it is a little bit, it takes a while, it's a little bit tedious, but it's not difficult. It just is time consuming. So your brain might get a little bit of a break this lesson. So prime numbers is very important though. So what is a prime number? If you're not familiar or need a refresher, a prime number is one that is only divisible by two numbers, 1 and itself. So for example, 3 and 5. So let me get my pen. All right, so 5 is not divisible by 2 or 3 or 4. It is only divisible by 5. 5 divided by 5 is 1, and is divisible by 1. 5 divided by 1 is equal to 5. Those are the only two numbers, the only two integers that 5 is divisible by, with no remainder. So that means that 5 is a prime number. So a number such as 6 is not a prime number because it is divisible by 6, and it's divisible by 1, but it's also divisible by 2 and by 3. 6 divided by 3 is 2. So this is not a prime. It is called a composite number. We'll see that right here, actually. A composite number is one that is not a prime. You can, it has other factors. So 1 actually is not a prime because a prime number has to be divisible by exactly two integers. 1 and itself. 1 is divisible by 1 and is divisible by itself, but 1 and itself are the same number. So it's not two different numbers. So 1 isn't classified as a prime number. 2, however, is. Because 2, the only thing that 2 is divisible by is 2 and 1, is itself and 1. So 2 is a prime number. 2 is also the only even prime number because 4 is divisible by 2, 6 is divisible by 2, 8 is divisible by 2. Every even number will always be divisible by 2, right? That's the divisibility test for 2, is that if it's an even number, you know it's divisible by 2, or a multiple of 2, however you want to phrase that. All right, so again, a prime number is a positive integer that is divisible by exactly two positive integers, 1 and the number itself. A composite number is anything else, basically. All right, so list every prime that is less than 20. All right, so let's just go one by one. Well, we know that 1 is not a prime, so that's not good. 2, we know is a prime, so that's good. 3, we said in the last slide, is a prime. It's not divisible by anything except for 3 and 1. How about 4? 4 is divisible by 2, so that's not a prime. How about 5? Well, 5 is not divisible by 2 or 3 or 4, so yeah, 5 is a prime. How about 6? Well, really, let's go ahead and skip all the even numbers now because we know 2 is the only even prime. So 6 is not going to be a prime. How about 7? Well, it's not divisible by 2 or 3 or 4 or 5 or 6. So yeah, 7's a prime. 8 is divisible by 2, so that's not a prime. 9, is 9 a prime? 9's a tricky one. 9 will get you sometimes, but remember, 9 is not a prime. 9 is divisible by 3, so 9 is not a prime. You get in the habit of listing primes and you say, oh, 3 is a prime, 3, 5, 7, and you want to say 9 because it's right there. It's the next odd number, but 9 is not a prime. What's after that? 10. Well, 10 is an even number, so that's not a prime. And also we know that, oh, never mind. I was thinking about divisibility tests. No, 10 is not a prime because it's an even number, divisible by 2. So then 11. Let's see. Is 11 divisible by 2? No, it's not even. How about 3? Remember the divisibility test for 3? We add up the digits, so 1 plus 1 is 2. It's not a multiple of 3. All right, how about 4? Again, not an even number. 5, it doesn't end with a 5 or 0, so it's not divisible by 5. 6, well, multiples of 6 would be 6 and then 12, so no. Plus it's not an even number. How about 7? It'd be 7 then 14, so no. 8, no. 9, no, and 10, no. So 11 seems like a prime to me. 12, 12 is even, so no. 13, well, let's see here. Again, it's not an even number. How about 3? So 1 plus 3 is 4, but 4 is not a multiple of 3. Also not a multiple of 9, okay? How about 4? Not an even number. 5 doesn't end in a 5 or 0. 7 would be 7, then 14. 8, not even. 9, then 18. Plus the divisibility test for 9 would be 1 plus 3 is 4. It's not a multiple of 9. It doesn't end in a 0, so it's not a multiple of 10. And it's not a multiple of 11 or 12. So 13 is a prime also. How about 14? 14 is an even number. 15, is 15 a prime? Let's see. So it's not divisible by 2. How about 3? So 1 plus 5 is 6. Oh, and that is a multiple of 3. We also know that 3 times 5 is 15. So that is not a prime. 16 is even. 17. Ooh, let's see. 17. So it's not divisible by 2. How about 3? 1 plus 7 is 8. And that's not a multiple of 3 or 9. So we can rule out those two. It can't be 4. It's not even. It's not 5. It's not 6. Not 7, because it would be 7, then 14, then 21. So it's not a multiple of 7. Not 8, because it's even. 9. Again, the test was 1 plus 7 is 8, and that's not a multiple of 9. It's not divisible by 10, because it doesn't end in a 0. 11, it's not a multiple of 11. 11 and then 22. 12 is even. 13 would be 13, then 26, so no. 14, no. 15, no. 16, no. So 17 is a prime. 18 we know is not, because that's even. How about 19? Well, let's see. Not divisible by 2. 3, 1 plus 9 is 10. That's not a multiple of 3. Also not a multiple of 9. So 4, no. 5, no. 6, no. 7, no. Be 14, then 21. 8 is even. 9 we already did. 10 doesn't end in a 0. 11, then 22. 12 is even. 13, and then 26, no. 14 is even. 15, and then 30, no. Actually, a lot of these that we've crossed off already, if they're not primes, then we don't even really need to check them, because if it's not divisible by 3, then we know it's not going to be divisible by 9. If it's not divisible by 2, it's not going to be divisible by any even number. If it's not divisible by 5, it's not going to be divisible by any multiple of 5. Same thing with 7. So a lot of these, we really only need to check what we haven't crossed off already. All right, so that's 19, and that's the last one. Next number will be 20, and it says less than 20. So we have 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8 primes that are less than 20. And again, so like I mentioned at the beginning of this lesson, a lot of these problems aren't going to be difficult, but some of them can be time-consuming. There's only 7 slides here, so should go pretty quick, but some of these take time. And yeah, I'm sure you could have done this faster than I did. I just wanted to take it nice and slow and make sure that we understand how we're doing this. So next question here. Mina is trying to determine whether or not 113 is a prime. So checking for divisibility for each positive integer, she starts with 2. So she sees that 113 is odd, so she knows that it's not divisible by 2. Then she checks to see if it's divisible by 3, just like we did in the last slide. Let's go ahead and add up the digits. So 1 plus 1 plus 3 is equal to 5, and that's not a multiple of 3, so it's not divisible by 3. She says she knows that 113 is not divisible by 3. Yeah, okay, yeah, we just did that. So now A, since 113 is not divisible by 2, I know that 113 is not divisible by 4. Is she right? So take a second to think about that one. If it's not divisible by 2, does that mean that it's also not divisible by 4? Yeah, we talked about that last slide, that if it was divisible by 4, it would also be divisible by 2. If you remember back in 3.1 when we talked about multiples, we discussed that every multiple of 4 will also be a multiple of 2. If you think about it, you have 4, 8, 12, 16, 20, 24. And if like all those numbers, you can tell they're all even. They're all going to be multiples of 2. Just like all multiples of 9 are going to also be multiples of 3. 9 is a multiple of 3, 18, 27, 36, 45. These are all multiples of 9 that are also multiples of 3. So yeah, we can say that if it is not a multiple of 2, then it cannot be a multiple of 4. Okay, so B, how does Mina know at a glance that 113 is not divisible by 5? That's a pretty simple one, right? It doesn't end in a 5 or 0, so it's not divisible by 5. She then says, since 113 is not divisible by 2, I know that is not divisible by 6. Well, same thing as A. We know all multiples of 6 will also be multiples of 2. So 6, 12, 18, 24, those are all multiples of 2. So if it's not a multiple of any 2, then it's also not going to be divisible by 6. Okay, so Mina divides 113 by 7 and finds a remainder of 1. So she knows 113 is not divisible by 7. She then says, I don't have to test 8, 9, or 10. I know that 113 isn't divisible by any of those. How does she know that? How does she know that it cannot be 8, 9, or 10? Well, 8, same reason for C and A, right? 8 is a multiple of 2. And if 2 is not divisible by 2, then it can't be divisible by 8 or 10 for that matter. Also 10, it would end in a 0 if it was a multiple of 10, right? So 10 can't be it for multiple reasons. How about 9? How does she know that it can't be divisible by 9? Well, we already know that it's not divisible by 3, and 9 is a multiple of 3. So if it's not divisible by 3, it can't be divisible by 9. We added up the digits. 1 plus 1 plus 3 was 5, and that's not a multiple of 9. Okay, this last one though, Mina says that since 11 squared is 121, I don't have to test any numbers higher than 10. I now know that 113 is prime. So why doesn't Mina have to test any more numbers? Go ahead and take a second to see if you can think about this. Why is it 11 squared that is the final thing that she needs to check, and knows that she doesn't even need to check 11 or anything higher than that? So the answer to that is that she knows 11 squared is 121, and 121 is greater than 113. She doesn't need to check 11. Why is that? What about like 11 times 9? How does she know that that wouldn't be it? Well, we know 11 times 9 is 99, right? But we know it won't be 11 times 9. Even if we didn't know what 11 times 9 was, we know that it can't be 11 times 9. Why? Because we know that it's not divisible by 9. We know it can't be 11 times 10 because we know it's not a multiple of 10. We know it's not 11 times 8 or 7 or 6 or 5 or 4 or 3 because we already checked all of those. So it can't be 11 times anything less than 11 because we've already checked everything else. So the only thing that we would need to think about is 11 times itself or 11 times anything higher than itself. Because again, we already checked everything lower. So we know it's not going to be 11 times anything lower than 11. So maybe 11 times 11, but we know 11 times 11 is 121, and that's higher than 113. So because we are already past 113, we don't need to keep going, because we know if 11 times 11 is higher than 113, then 11 times 12 is going to be higher. 11 times 15 is going to be way higher. 11 times a billion, like there's no need to keep checking numbers after we get to a number that's higher than 113. So that's the reason why we don't need to check 11 times anything lower than 11. And that's the reason why we don't need to check anything that's anything higher than 11, because we're already past it. All right, so hopefully that makes sense why 11 squared is important to know that we don't need to keep going because 11 squared is higher than 113. So 113 is a prime. And also go ahead and check out this video to learn more about how to tell if a number is prime. Okay, so now let's check each of these numbers to see if it's a prime or a composite. So go ahead and pause this and give it a shot. All right, so first one is 61. Okay, so 61, let's go one by one and check our divisibility rules. So it's not divisible by 2, it's not even. How about 3? So 6 plus 1 would be 7. So that's not a multiple of 3. How about 4? Well, again, it's not even. So how about 5? It doesn't end in a 5 or 0, so it's not 5. How about 6? Well, again, it's not even. 7? So 7 we don't really have a test for. So let's just try 61 divided by 7, because it should have no remainder. Let's see. So 7 times 8 would be close. 7 times 8 would be 56. But it's going to give us a remainder of 5. We can't go any farther than that. So 7, it's not divisible by 7. 8, well, it's not 8 because it's an even number. Or 61 is not an even number. How about 9? The test for 9 is add up the digits. That'd be 6 plus 1 is 7, and that's not a multiple of 9. Okay, we know it's not a multiple of 10 because it doesn't end in a 0. So now we're at 11. So again, same thing we did in the last slide. 11 squared we know is 121, which is higher than 61, so we don't need to check anything else, which means 61 is a prime. Okay, how about 91? So 2 is not going to work. 3, 9 plus 1 is 10. It's not a multiple of 3 or 9, so we can rule those two out. 4, no. 5, no. 6, no. 7, let's divide again. So 91 divided by 7. Well, we can go into 91 at least 10 times. Start there. That will give us 70. 21 is left over. And there we go. 21 is a multiple of 7. 10 plus 3. So that'd be 13 times 7 would end up being 91. So this would be a composite because 13 times 7 would be 91. All right, how about 143? So 143, so it's not even, so it's not 2. How about 3? So 1 plus 4 is 5, plus 3 is 8. It's not a multiple of 3, and not a multiple of 9. Okay, not 4, not 5, not 6. How about 7? So 143 divided by 7. Actually, we can kind of just look at this and know, because 7 we know goes into 14 with no remainder, so that would give us no remainder, and then 3 would be left over, and that's not a multiple of 7, so that would have a remainder. So that is going to not be divisible by 7. All right, how about 8? Not going to work. 9, we already did the test for 9 along with 3. 10 doesn't end in a 0. 11, okay, let's try 11. 143 divided by 11. Okay, so this will go in at least 10 times. So that'd be 110. Would leave us with 33. Oh, that looks like a multiple of 11, right? That's 3. 3 times 11 would be 33, no remainder. So 11 times 13 would be 143. So this would be a composite, not a prime. Composite. Also, quick side note, if you're not already familiar with the 11's multiplication trick, it's really handy. So I figure I'd mention it right now. So if you want to multiply 11 times a number, let's say 11 times 34. There's actually a trick to this. The answer to this would be the first number of the number you're multiplying with, so 3. The second number would be the sum of the digits. So 3 plus 4 is 7. And then the last number would stay the last number. So it would be 374. And this works for all these 2-digit numbers. 11 times, let's say, 95. So one problem when you do actually need to carry, like you do with addition, but it still works. So the first digit here would be 9, but then the sum of the digits would be 14. So actually you need to increment that 9 to a 10. And then, because that would be 14, right? Because 9 plus 5 would be 14. And then the last digit would be 5. So 1045 would be 11 times 95. Neat little trick to be able to do 11 multiplication in your head. So if I were to ask you, what is 11 times 21? You know that would be 231, right? The 2 plus 1 is 3, so that's your middle number, and 2, 3, 1. All right, so and we can make sure that this is right. Let's do 95. This is, I know, not important, not related to this lesson, but still a cool trick to use if you ever need to. 1 times 5 is 5. 1 times 90 would be 90. 10 times 5 would be 50. And 10 times 90 would be 900. That's a 9. All right, so we have 5. We have 14. And we have 10. 1045. So, yep, that checks out. It works. So anyways, moving on. So again, so we know that 11 times 13 would be 143. All right, so then this last one here, 157. So not divisible by 2, it's not even. How about 3? 1 plus 5 is 6, plus 7 is 13. That's not a multiple of 3 and not a multiple of 9. All right, so how about 4? No. 5? No. 6? No. 7? Let's try it. 157 divided by 7. All right, it looks like we can put 20 into this, so that'd be 14 and a 0. Leave 17, and it looks like that's not going to be evenly divisible by 7. 14 is going to give us a remainder of 3. All right, so not 7. How about 8? Nope, it's not even. 9, we already did the check for 9. 10 doesn't end in a 0. How about 11? Well, we already know that 11 times 13 is 143. 11 times 14, we can do on our head now, would be 154. That'd be close. But then 11 times 15, it would be 165. So not divisible by 11. And we did need to check 11 because 11 squared is 121. So this is higher than 11 squared. So we did need to check 11, just like we needed to check 11 the last problem. But do we need to check, well, don't need to check 12 because it's an even number. How about 13? Do you remember 13 squared? If you don't remember, you can just do it real quick. 13 times 13 would be 9. 3 times 10 is 30. 10 times 3 is 30. And 10 times 10 is 100. That would give us 169. And that is higher than that. So we don't need to check 13, which means this is a prime. All right, so find the largest 2-digit composite number in which both digits are prime. Okay, so each digit, so it has to be we need to get single-digit primes. What are the single-digit primes? So we've got 2, 3, 4 is not a prime, 5 is a prime, 6 is not a prime, 7 is a prime, 8 is not a prime, and 9 is not a prime. All right, so we have these 4 options for primes to make a 2-digit number. Well, let's see, what's the largest 2-digit number? Well, 77, I think, would be a number that is 2 digits and both prime. And would it be composite? Well, 77 is not prime because 11 times 7 is 77. So I think that works. 77 would be the largest 2-digit composite number in which both digits are prime. All right, 3.18. Find all pairs of primes whose sum is 61. Go ahead and see if you can come up with an answer for this one. So this one, if you recognize one little trick, then this one is actually pretty easy. But it's a kind of a tricky trick to find, something that you might have known and maybe forgot, or maybe you never knew this. So we'll go over it now. So in order to have something to sum to 61, well, some things that it can't be. So you can't do an even number plus an even number. So if you have something like 4 plus 6, if you do an even number plus an even number, you will always get an even number. Right, so 2 plus 22, 2 even numbers would give you 24. You would always get an even number if you add 2 even numbers. How about if you add 2 odd numbers? So 3 plus 7, let's say, that would be 10. So you do 19 plus 5. That would be an even number. It'd be 14. So if you add 2 even numbers, you get an even number. If you add 2 odd numbers, you get an even number. So the only way you can make an odd number is if you add an even number plus an odd number. So that means that to make 61, we have to have at least one, well, we have to have exactly one of those numbers be an even number. One has to be an even, one has to be an odd. So what options do we have for even number primes? Well, there's only one option, right? 2 is the only even number prime. So because that's our only option, then we only have one option. We have 2 plus 59. That is the only way to make 61 with primes. Assuming that 59 is a prime. Now, is 59 a prime? Well, I sure hope so, because if it's not a prime, then nothing's going to work. But let's go ahead and check to see if 59 is a prime. So 59, it's not even, so it's not divisible by 2. How about 5 plus 9 is 14? That's not a multiple of 3 or 9. 4 doesn't work. 5, no. 6, no. 7, do 59 divided by 7. So let's see, we have 7 times 8 would be 56. with a remainder of 3, so not divisible by 7. That's good. 8, no. 9, we already checked. 10, doesn't end in a 0. 11, well, we know 55 is a multiple of 11, and we know 66 is a multiple of 11. And we also know that 11 squared is already bigger than 59, so we can actually stop there. So 59 is a prime, so that's good. 59 is a prime. We know 2 is a prime, and they sum to 61. So that's really the only option we have is 2 plus 59. Okay, for this one right here, the goal is to start at the beginning, and if the number is not crossed out, which we just started, so nothing's crossed out. If it's not crossed out when you get to that number, then circle it. You circle it, and then you cross out all of its multiples. So we'll cross out 4, 6, and so on. And then once we're all done crossing out all the multiples, then circle the next number that's not crossed out. In this case, it'll be 3. So go ahead and give this a shot if you want to try it yourself. It's a little bit time consuming, it takes a little while, but it's not that difficult, it just kind of takes a long time. One thing that I do with my son, and make sure that you are allowed to do this, you ask your parents permission if you need to. What we do sometimes is use a dry erase marker and write on the screen. So if you're watching this on a tablet or something like that, sometimes we just write directly on the screen and then we can just wipe it off afterwards. Again, don't do that if you're not supposed to do that, but it's an option if you are. So anyways, I'll go ahead and do this. So we'll cross out 4, 6, 8, 10, and actually lucky for us, all these even numbers are nicely put into these columns here. So we can just cross out all of these, save some time. And the 8's column, and the 10's column. Okay, so that's all of our multiples of 2. So now we would circle the next number that's not yet crossed out, so that's 3. And now we cross out all the multiples of 3. Half of them are already going to be crossed out, but we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 70, 72, 75, 78, 81, 84, 87, 90, 93, 96, and 99. All right. So now on to 5s. Well, that's nice and easy. All of our multiples of 10 are already crossed out, and all of our multiples of 5 are right here in this column. Okay. 7s. So we have 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, and 98, and we're done. Okay, 11s. So this is time consuming, but it's a nice way to find all of your primes, because we know if you get to it and it hasn't been crossed out yet, it hasn't been a multiple of anything else yet. So anyways, we can go ahead and cross out our 11s, which is nicely on this diagonal right here, but it looks like they're all crossed out already. So those are all covered. So 13. And we're gonna have less and less to cross out as we get higher and higher. So 13, then 26, and then, so if we're at 26, then we're at 39 would be next. And then 52, 65, 78, 81, or 91, and then we'd be over 100. 17 is next. 17, and then 34. And then 51 would be next. And then 68. And then 85 would be after that. And then we'd be over 100 after that. So then 19. Okay. Well, if it was 20, the next 20 would be 40. So 2 less than that would be 38. And some of these we can recognize some patterns. So for this one, for example, we go down 2 and over 1. Down 2, over 1, down 2, over 1, down 2, over 1. So that's already taken care of. 23. Next one will be 46. Be right here. And probably the same pattern here. We can go, what was this? Down 2, over 1, 2, 3. Yep. Down 2, 1, 2, over 3, 1, 2, 3. And that would be right? From 46 to 69. That would be adding 23. But too bad we don't have more to go to the right. So 23 plus 69 would be, let's see, 70 plus 23 would be 93. So it would be 92. And then after that would be over 100. Okay, so then 29. So instead of it being 30 plus 30, which would be 60, it would be 58. That's taken care of. 86 would be next, and then over 100. So then 31, and then we have 62, and then 93 is already crossed out. Okay, then what's next? This is crossed out already. 37. 37, and then 74 would be next, and then over 100. 41, and then 82, and then over 100. 43, and then 86. 47. So again, so these odd numbers, we know that the next number is going to be even, because an odd plus an odd is an even number. And it's high enough now so that we know we're not going to get to the third number, because it'll be over 100, right? So we know 43 plus 43 is going to be an even number, because an odd plus an odd, which is 86. And we also know that the following number after that is going to be over 100. So we can sort of save some time here. 47 plus 47 is going to be an even number. We know that's already crossed off, so we don't need to check anything. 53 is over 50, so even the next number we know is already going to be over 100. So now at this point, we just circle the rest. 67, 79, 89, 97. Am I missing anything? All right, let me go check my answer key to make sure I got everything. All right, we should have 2, 3, 5, 7, 11, 13, 17, 19. Good. 23 and then 29. Good. 31 and 37. 41, 43, 47. 53, 59. Good. 61, 67. 71, 73, 79. 83, 89. And 97. All right, looks like that was it. So again, takes a little while, but we got a lot of prime numbers there. And we didn't have to do a bunch of divisibility tests to find out if 67 or 83 were divisible by anything else. So this is another neat way to find primes, especially larger primes. So finding large primes is actually a difficult math problem. It's hard to know if 1, 9, 4, 7, 2, 1. Like, is this a prime? It would take a lot of divisibility tests to be able to figure out if this is a prime or not. And that's actually a complicated math problem that is used a lot in like cryptocurrency. A lot of times, some algorithms will be run to find large primes, much larger than this even. And it's a difficult thing that takes a lot of computing power. You can write programs that will find primes, but even those can be slow and very computationally intense. That's why you might have heard about crypto mining and how you need a lot of like graphics cards and a high power computer to do it, because it's doing a lot of these calculations to solve for primes. So it's kind of a neat problem, kind of out of scope of this course, but I figure you might find it interesting. So this process is called, I don't know how to pronounce this, the Sieve of Eratosthenes. And it's an efficient way to generate long lists of prime numbers, very high prime numbers. You write a computer program, and maybe I'll make a video. I am a programmer, so maybe if you're interested, I can make a side video that wouldn't be part of this course. But if you're interested in coding, maybe we'll put together a program that can calculate primes like this. So it might be a fun thing to do. But in any case, we got through this problem and moving on to the next one. Oh, that's it. So we made it through prime numbers. Hopefully that wasn't too challenging, but go ahead and try these 3.3 exercises. Again, shouldn't be too difficult. A lot of the same things that we've already been doing. And I will see you in 3.5 or 3.4.